Solve the absolute value inequality. Give the solution set in both interval and graph forms. Here we have the absolute value of 4x plus 3 is less than or equal to 7. Now, if the absolute value of a quantity is less than or equal to 7, then it will take on values ranging from -7 to +7 inclusive. So let's write an inequality statement describing that. So 4x plus 3 must take on a value that is less than or equal to 7, but greater than or equal to -7. Now let's solve this three-part inequality for x. Start by subtracting 3 from each piece. On the left, -7 minus 3 is a -10. In the middle, our 3's cancel, leaving 4x. On the right, 7 minus 3 is 4. Now let's divide each piece by 4 to isolate that x value. So on the left, we'll have a -10 over 4. We've isolated x in the middle. And on the right, 4 over 4 is 1. Let's do one more thing here, and let's reduce this fraction and say that x is a number that is greater than or equal to -5/2. I've canceled a common factor of 2 out of each the numerator and denominator here. And x is less than or equal to 1. Now, we want to write the solution in interval form also. So let's do that by saying with a bracket to the left of this 5/2 showing that this -5/2 showing that it is included up to 1 inclusive. Graphically, we'll use the same notation with the brackets to describe this interval. I'm going to start by determining where 0 is, and there's our 1 unit to the right. Now if we go 1, 2, 3 units to the left, that -5/2 is going to be between -2 and -3, right here, halfway between them. So use brackets on your graph to show that those endpoints are included, and bold this area in between them, showing that all solutions are values ranging from -5/2 to +1 inclusive.